Assalamu alaikum, dear students. Today we are starting a new chapter of our advanced weaving two studies. Its name is Rapier weaving. In this chapter, we will understand the Rapier weft insertion system. How does it work, and what are different components, and what are their different types? How this Rapier system, Rapier weft insertion system, is better than other weft insertion systems, and we will try to understand its working and their advantages and disadvantages, and we'll try to develop understanding how rapier weaving is different from the other type of weft insertion systems. So let's get started. So rapier weft insertion system is one of the oldest known weft insertion system, shuttleless, that is shuttleless, and after the projectile weft insertion system, Rapier is the oldest known weft insertion system. How does it work? Is Rapier weaving uses mechanical grippers. You can see there are mechanical hands that can grip the weft that is to be inserted as rapier heads. These gripper works as rapier heads, and they take weft from one end of the fabric to the other, one side of the fabric to the other side. That is for the weft insertion. So generally, in today's common type of practice of rapier weaving, we have a head that is we have a gripper that works as a head on a foldable flexible strip that can be folded in an housing, and from there it can open, unravel, and then it can take it can advance the head towards the receiving side, and on the upon the return it takes the weft along it, and then coiling this strip, pulls this head towards the picking towards the receiving side of the weft, toward the other side, and that's how weft is inserted. Earlier, rapier weaving was not very popular. It is since 1972 it has become a flexible weaving mechanism that is versatile and that is very successful. Its earlier problem was a very large requirement of the space. Almost double the width of the machine space requirement is for a single machine, and its speed was not high because mechanical systems are mounted on the sleigh that hinders its fast movement, and that is why high peak insertion was not possible then. But with the introduction of flexible rapier, the size of machine reduced and machine speed increased, and the most valuable thing for the rapier weaving that has been and still now available is the wide range of fabrics for which this machine can be employed for. For example, it can weave a very lightweight fabric like gauze fabric from only 20 GSM to very high industrial fabrics to up to 850 grams per meter square. So rapier weaving is versatility is its a wide range of fabrics that can be manufactured using this weft insertion system, and other also include. So generally, this mechanism, this weft insertion system is used for household textiles that require heavy fabrics, and also industrial fabric that require very high GSM of the fabrics. Uh, so it's also one versatile ability of rapier weaving is a very large range of weight change in the fabric. Another thing is the various type of weft insertion Very different type of weft insertion can be done with the weft can be inserted with the rapier weaving, which involves cotton, wool, man-made fiber, technical fibers, for example, silk and maybe fancy yarns. So very rigid, very soft, normal, heavy, all type of almost all type of wefts can be used because it use the gripper that takes the weft from one side and take it to the other side, like carry it to the other side. A very delicate system to let the weft be introduced in the shed. So it is the most delicate way of inserting the weft. That is why least change in twist, less least change in texture of a fancy yarn. So this is very delicate and very good system that does not alter the characteristics of a weft yarn. So this preference of rapier weaving is for its care for the weft it can maintain during the insertion of the weft. With the introduction of lightweight grippers, and that has a balance at the center. The center of gravity is very balanced. These tapes are these are tapes that are with the help of extended guides that can work with the help of extended guides, and it also combined with support the teeth from the lower shed, and all these things provide a very smooth insertion that is a very friendly gripper that insert the weft very easily and at high speed. All these variations and technology has made the rapier weaving very good weft insertion system that can work very swiftly. And this adds to the control of the yarn with the minimum stress inserting on the weft yarn. So this minimum stress insertion makes the rapier weaving very it's very advantage, and that is why the yarn can be inserted without much change in its characteristics, and that is why the grippers possibility, you can see over here a grippers head that can engage with the yarn. So you can adjust its spring pressure. This spring pressure adjustment enables it to uh, to, to to interact with a very fine yarn to very coarse yarn, only from only 5 tacks to 1000 tacks. And it is possible to use 16 different type of weft insertion at a time on a weaving machine. That is 16 weft insertion, 16 different type of weft can be inserted. And with the advancement of the weaving technology, you can use for the harness system, you can use up to 28 harnesses that make the rapier weaving very versatile. Today the weft insertion rate has become uh, maybe beyond 1400 meter per minute, and with the cam shedding, and maybe it can also work at higher rates with the other shedding systems with the very low breakage of the warp threads or weft threads. And for the latest machinery, the material that is used to insert to make the strip and the head is maybe a combination of composites and metal that make it very lightweight and robust and very efficient to grip the weft. So maybe the new system use um, air pressure to minimize the friction between the strip and the holders from where the strip is released. So the minimum friction has made this system with low waste of energy and very efficient. So all these things has been being added, and and the system is getting improved. You can see here is the head gripper hook that carries the web at the center from an introducing hook. This hook takes the web from left side to the center, and from the center to the right side this hook is carries the weft. Two grippers works in new type of machine so that the machine insertion rate can be increased. So now we will talk about we will see a video and then we will talk about in detail more about the rapid weaving. Dear students, in this slide I am introducing you with the how this rapier weaving work. In flexible rapiers, we have the rapier that can fold. You can see in this video the this rapier wheel is winding and unwinding the rapier strip, and unwinding causes this head to move forward on the sleigh for catching the weft, and rotating this wheel on the other side returns the head in the opposite direction. So we have two such rapier strips coming from the both sides. One carry this yarn along it to the half of the machine, and from the halfway the right side grabber catches it and take it to the right of the machine. So that's how the this simplified working is shown over here. So we will see the more working in more detail in the coming slides. Dear students, before we actually talk about different type of Rapier system, let's have an overview of how these systems are. So generally, if we want to classify, categorize different type of Rapier systems, we can categorize them on different bases. For example, we can categorize them on the base of their number of rapiers. Rapiers can be rapier weaving can use only one single rapier head that is inserted from one side. It goes all the way to the receiving side and picks the weft and then goes back to insert the weft in the hole width. Single rapier that is that is entering from one side, reaching to the other side, gripping the weft and taking back to the and getting out of the shed. Full width only one gripper. This is called single rapier system. This is an old system and not very much employed these days. Generally, for the production for making fabric at higher speeds, we use double rapier system. Double rapier system use two rapiers. One rapiers take the weft to the center of the machine, and the other rapier that is coming from the other side approaches at the center. It catches the weft there from the rapier coming from the left side, and then take it to the right side of the machine. That's how the weft is inserted. So two rapiers are used in these systems. These two rapiers can have two principles. One is called Davis system and one is called Gabler system. Davis system basically use is the rapier head that is taking the weft from the left side actually take the edge or the finishing end on the take this finishing end along it, and then handed over this edge to the other rapier, and then second rapier take it to the right of the machine. In Gabler system, the edge or the end of the weft is not taken by the rapier. A loop is a folded yarn is dragged to the center from where the loop is handed over to the right gripper, and then the this free end was folded on the left side on the picking side. Once the thread loop is handed over to the right gripper, this free end is released, and now this folded yarn becomes single yarn, and one single weft is inserted in the full width. So this is the gablet system. This was used earlier. These days Gablet system is not in practice. All the double rapier systems work on Divas system principle. Then if we look at how the head approaches for the weft to carry it, there are three systems. The rigid system is the one system in which the head is attached to a single straight rod or pipe or a strip, maybe square strip, and this strip is rigid and it does not turn or fold, and for the it generally is used for single rapiers only. So the single rapier system are single rigid system. So single rigid system use one head that that is again enters from one side and reaches to the full width of the machine, does not folds. Rigid systems. So flexible system generally use a housing in which the strip on which the head is attached. Its other end can be folded, can be coiled on one side, and then generally it is double system. If it is a double system, the two coiling are done on the right and left of the machine for the two grippers, and this uncoiling or unwinding this coiled strip cause this grippers to move to the center of the machine or otherwise folded into its housing. Telescopic rapiers are like, if you can imagine, the antennas that are attached to the radio systems. Generally old tapes or old decks have this radio system on which the telescopic antenna is there, which can fold inside it and become smaller, or you can expand them to open it to a larger length. To this principle, this is called telescopic. So on telescopic principle, it was also possible to use rapier, but this system makes the slave very heavy and can hinders the higher RPM of the machine, and that is why it is no more in use. But in old machines, you can find the telescopic method of rapier system that used to fold the uh, strip or the guide on which head the gripper is installed, telescopically fold on the right and left edge of the machine. This is not more used anymore. This is not used anymore. So this is the introduction of different type of rapier system. Uh, in the next slide, I will show you an summary of or introduction of all these system. Then we will start about individually for each system. We will talk about in more detail in each system afterwards. Dear students, let's watch a video. This
In
video
this
will
segment,
introduce
we
you
describe
about
how filling
different
yarn
rapier
is
systems,
actually inserted into the
and
fabric.
it will make a
Several
comparison.
systems are used to insert the
Let's watch
filling.
this video.
These include shuttle, rapier, projectile, air jet, and water jet. Rapier filling insertion is one of the most versatile of insertion types. This is due to the rapier head gripping the yarn and carrying it across the width of the shed. Therefore, any yarn, from extremely fine to very coarse, can be woven. Also, very different yarns can be woven from pick to pick without readjusting the rapier. There are 4 types of rapier systems: single rigid, double flexible, and double telescoping rapiers. The single rigid rapier uses a solid rod material that carries the yarn completely across the warp. This loom footprint requires twice the floor space of the rapier due to the fact that when the rapier is not in the shed, it is housed in a sheath external to the shed. Double rigid rapiers use 2 rapiers that are just over 1/2 the width of the warp. Each transfers the yarn halfway across the warp shed. This still takes up the same amount of floor space as a single rigid rapier because each rapier is stored on either side of the loom. However, the speed can be increased because it takes less time to insert a pick, since each rapier has only half the distance to travel in the shed. Double flexible rapiers use a flat metal tape or high-tech composite material to transfer the yarn across the warp shed. The advantage of this system is that the floor space is reduced since the rapier storage space is reduced. Because the rapier is flexible, it is coiled into a circular sheath when not inserting the filling. The rapiers are much lighter, resulting in higher processing speeds. Flexible rapier looms are capable of reaching 850 picks per minute on single-width fabrics. Double telescoping rapiers use sliding or telescoping devices to insert the filling yarn. They're similar to double rigid rapiers, but since they telescope, much of their length is stored inside the rapiers themselves as the rapier collapses, thereby reducing the width of the loom. This type of rapier loom can only achieve a maximum of 350 picks per minute due to the weight of the rapier and the time required to extend and contract it.